Hello everyone, I'm Gergo, and I'm here to talk to you a little bit about how we can modernize healthcare via data science. One of the main goals was to go from a diagnostic-based diagnosis, categorize people into certain disease diagnosis, and how we can change that into using a predictive prognosis-based healthcare, which means that everyone will be looked at individually and they receive a personal treatment based on what their set of diseases are. But first, we're actually here not only to hear about amazing data science, but also to get to know each other a little bit. So I wanted to tell you how I and many others in this room think. I think we all believe in the scientific process. I mean, it evolved over the past 3,000 years, and it has been fairly successful. It gave us spaceships, it gave us the Game Boy, so we can all be happy. And ultimately, what I want to confer to you is that this applies not only in academia, but it applies to anything that your organizations might do. So let's look at the hiring process. Imagine a scenario where you're sitting in a room and there's a poor nervous guy presenting to you, and you have a hypothesis that, oh, this guy might be a good fit for my company. You have this hypothesis, I cannot point, and then you make an experiment. Your experiment in this case would be to hire the person and let's see how he does. Over the next several months, you gather some raw data, you see how he solves problems, you give him how he interacts with coworkers, and then after an evaluation period, you structure all your raw data, you create a report, and examine whether you want to keep this person. Essentially, you make a prediction on whether this person will perform reasonably in 1 year's time, and say you come to the conclusion that he won't. So internally, you update your model because originally you came up with the hypothesis that this person would be a good fit, and it proved over time not to be true. So when you get to the next hiring process, and you have to make a hypothesis about the next person, you will have a different model, and maybe you will reject similar people from even trying them and wasting your time. So how did I come to think this way? Well, when I was 7, let's start at the university level. So I went to university originally. My undergrad was in molecular bionics, which is a very buzzwordy thing in Hungary. It's a very new course. And basically, I studied everything. It was very interdisciplinary. I studied chemistry, biology, neuroscience, physics, computer science, and whatever else you can imagine. And we're also focusing on how to help people. That was the main goal of the project. Afterwards, I continued my training in theoretical neuroscience and machine learning. So as you can see from the two fields, it's still kind of interdisciplinary. And I've done a lot of basic research, but I felt that I want to be more applied and help people, and that's how I ended up at Warwick. So during my previous 10 years, I've literally done academic projects in all of these fields. Most relevantly, maybe that I've analyzed a lot of time series, as you've seen before. And this time series analysis, I now want to apply to sick people and see how we can predict what is going to happen to them. The project I'm involved in is called Scottish Patients at Risk of Readmission or Admission. I think one of those letters were added to make it sound better. It's called SPARA. And a few years ago, about 10 years ago, Scottish NHS identified that actually, guys, we are dying earlier than English people. That can't be. So let's do something about it. And they wanted to identify people at risk and help them. So this was the SPARA project. It had 3 versions already. They tried to gather all kind of medical and non-medical demographic information on people in Scotland. And the earliest iteration was give a score for everyone, like how likely they are to die or to go to hospital. And then they use this score to certify people and give all of them the appropriate help. The level of help goes from they don't need any help or they can get online information to let's get a social worker to stay with them the whole time because they are at serious risk of having some serious outcomes. So the current project is to develop yet another, newer version of SPARA, and this is in collaboration with Warwick, NHS Scotland, and the Ellen Turing Institute, as well as HDR UK is starting to get involved, and maybe NICE. So we want to make individual predictions personalized predictions for 3.5 million Scottish patients. And also we want to make this research to be a gold standard on how to do medical research, how to do prognostic research properly. And what we are doing is actually, I have an easy job because usually the hard job is to gather the data, and due to the previous 3 iterations of the model, it has already been done. So actually all I'm doing is taking advantage of all these data sources and creating some AI that will understand. So as you can see in the scientific processing that I showed, Spara only goes from structured data, which is already provided, to making good predictions about individuals' health. So you can do this using time series data and ultimately model the individual's health progression over time and generate a personalized report for each one of your patients and treat them appropriately. Thank you very much.